In section 4.7, we're going to discuss how you graph what we call linear inequalities. And by linear inequality, I'm referring to the less than or equal to sign, greater than, and greater than or equal to sign. So these are probably mathematical signs that you're familiar with. And what we want to remember is that the less than sign points to the left and the greater than sign points to the right. And if we put this little line underneath it, like you see here and here, that means it also includes equal to. So looking at these, if I was to read this first one here, that is saying 3 is less than 5, which I would say is true. 3 is less than 5. The second one is saying -2 is greater than or equal to -4. Since -2 is further to the right technically on the number line, -2 is greater than -4. This would be true. This third one here is saying -1 is greater than 0. That's false. 0 is technically greater than -1. And this last one is saying -5 is less than or equal to -5. Well, since -5 equals -5, this is true. Alright, so we're going to use that idea and determine if the following are solutions to the inequality. So we're given this point, 2, 7. This is x and this is y. And we want to see if that point makes this inequality true. So we're going to plug in 7 for y. So 7 should be greater than 3 times 2 minus 1. That's saying 7 is greater than 6 minus 1. 7 is greater than 5. So since 7 is greater than 5, we would say this is a solution. Let's try this one, -4 and 5. We want to plug that into 3x plus 2y should be greater than or equal to 6. So 3 times -4 plus 2 times 5 should be greater than or equal to 6. That's -12 plus 10 should be greater than or equal to 6. -2 greater than or equal to 6. -2 is not greater than or equal to 6, so that point is not a solution. So we're going to use that idea, and that's going to show us how to create graphs of linear inequalities. So let's do that. So here's the process for graphing linear equalities. Number 1, graph the line the same way as if it was an equal sign. Except for one key thing. For less than or greater than, we're going to use a dotted line. For an equal sign, if you have a less than or equal to or a greater than or equal to, you're going to use a solid line. Then pick any point. And I should specify, make sure that that is not on the line. Pick any point that is not actually on the graph, on your line. And check to see if the inequality is true or false. If the point makes the inequality true, shade that side. If the point makes the inequality false, shade the opposite side. So let's see how this works. For example, we're going to graph the linear equality 3x minus 4y is greater than or equal to 12. We're going to start this by graphing that line as if it was 3x minus 4y equals 12. So I'm just treating that first as if it was an equal sign. So I would use the intercept method here because that's in standard form. So let's first find the x-intercept by making y equals 0. So 3x minus 4 times 0 equals 12. 3x equals 12. So x equals 4. So that gives us a point, 4, 0. We're going to put a dot there. Now let's find the y-intercept. For the y-intercept, I'm going to let x equal 0. So 3 times 0 minus 4y equals 12. So that means negative 4y equals 12. Dividing each side by negative 4 gives me y is negative 3. 0, negative 3 would also be a point. Now notice how that is a greater than or equal to sign. For a greater than or equal to sign, we're going to connect these points with a solid line. Now we're almost done, but we want to decide which way we're going to shade. To determine which way we're going to shade, we're going to pick any point on this graph that we want that is not actually on the line. So I'm going to pick one that's very easy math to do. And I'm going to pick the point 0, 0 right here and plug it in and see if it makes this equation true. So 3 times 0 minus 4 times 0 should be greater than or equal to 12. Well, that gives me 0 minus 0 is greater than or equal to 12. 0 is greater than or equal to 12. That is not true. That is not true. So we're going to shade the side of this line that does not have 0, 0. We're going to shade this side, and all of these answers over here would be considered solutions to that inequality. Let's try another example. We're going to graph the linear equality y is less than negative 3x minus 4. So the first thing we're going to do is graph that as if that was an equal sign instead of an inequality. So we're going to treat this as if it was y equals negative 3x plus 4. And so we'd have slope negative 3 over 1 and y-intercept of 4. And we know we start by graphing these with the y-intercept. And then since it's negative 3 over 1, it would be down 3 and over 1. So down 3 and over 1 would be this point right here. Now notice this inequality does not have the equal sign with it. For this one, you're going to connect these with a dotted line. Now we want to decide which side to shade. So again, I'm going to pick the point 0, 0 because that's just easy to do the math with. So if I pick the point 0, 0 and I plug it in, 0 is less than negative 3 times 0 minus 4. 0 is less than 0 minus 4. 0 is less than negative 4. Again, that is not true. 0 should be greater than negative 4. So in this case, again, I have to shade the side that does not include 0, 0. Remember, if it were to include that side, in other words, if that sign were to be facing the other direction, then I would shade the side that includes 0, 0. Let's talk about how this would apply to a vertical line. If I instead treated that as x equals 4, we would have a vertical line through 4. In this case, though, if you look at our sign, it doesn't include the equal sign. So what we're going to have is a dotted line through 4. Then I need to decide which side I want to shade on. So again, let's pick the point 0, 0. In other words, plugging in x is 0, y is 0. Well, I only have x is less than 4. Is 0 less than 4? That's true. So in this case, we're going to shade the side that includes that point. I would shade this entire side. We're going to look at a similar example now, but this would be a horizontal line through y is 2, if we treat that as an equal sign. Now, since it does include the equal sign, I must do a solid line. Now I'm going to choose any point to see if it makes the inequality true. Again, 0, 0 is just always an easy point to do math with. Is 0 greater than or equal to 2? That's false, so I have to shade the side that does not include that point. That would be this side here.